So today we're going to continue with section 2. Today what we're going to talk about are rational exponents. So in other words, exponents that are fractions. So here is the rule. So here it has a base of a, and then this m over n, this is the exponent. Now, what I like to do is sort of to help everybody remember which part becomes the exponent, which one comes the root. I think about this like a tree. So think of the roots of a tree are underground. So the root is going to be the denominator, and then the numerator of the fraction is going to be the exponent. So notice they've turned this into the square or the nth root of a raised to the m power. Now, when you go to do these, it's usually easier if you do the root first and then apply the exponent. However, there may be the occasion where you may have to do the exponent first and then the root. But generally, if you can take the root first, definitely do that. So have just a radical symbol like this one. The index, this little number or the root, the little number that's right here is called the index. So when it's a 2, you don't need to write the little 2 here. It's assumed to be a square root. But when the denominator is a 3, you're finding the cube root. Or if the denominator was a 4, you would be finding the 4th root. So the denominator of the exponent is going to be the root. And then the numerator, this will be what power you're raising that answer to, or the exponent. So here, just turning these into, from a rational exponent into a radical form, when you have 1/2 power, it's really finding the square root. When it's raised to the 1/3 power, it's finding the cubed root. And then this last one, you're finding the cube root, and then you're going to square the answer. So let's try some examples. So for the first one, notice this denominator of this exponent is the root, and then this is going to be the exponent. So I'm going to rewrite this, and I'm going to put the square root of 4, and then really what it is raised to the 1st power. And then you're going to evaluate the square root of 4, which is 2. For the next one, the 3 becomes the root, which is really the little index here next to the radical. And then you're going to square the answer. I'm going to find the cube root of 27. That's going to be a 3. And then I'm going to square the answer. Now, Friday we learned about negative exponents. We're still going to have negative fractions as well. But remember, when you have a negative exponent, doesn't make it negative, it turns it into a fraction. So the first thing I'm going to do is take care of that negative sign. And I'm going to move the 81 to the denominator. So then it's now 1 over 81 to the 1/4 power. And now that 4 is going to be the root I'm finding. And I'm going to be finding the 4th root of 81. And it's underneath that 1. The 4th root of 81, I know that 3 times 3 is 9, times 3, 27, times 3 again is 81. So the 4th root of 81 is going to be 3. So this final answer is 1/3. For the quiz on Thursday, you are not using a calculator. So if you cannot recognize that the 4th root of 81 is 3, you're just going to be doing some repeated multiplication on the side of your paper or on your scratch paper. And just start multiplying 2s and 3s. The numbers aren't going to be that large. For the next one, number 4, we're trying to find 16 raised to the 3/4 power. So again, the root will be 4, and the exponent is 3. The 4th root of 16 is 2. And then I'm going to raise that answer to the 3rd power, and I get 8. So we have 1,000. And again, notice it's raised to a negative power. So again, it doesn't make it negative, it makes it a fraction. So I'm going to first take care of that negative exponent. I'm going to move it to the bottom of the fraction. Make that exponent positive now. And now I'm going to find the third root, or the cubed root of 1,000. After I find that, I got to square it. But remember, it's still underneath that 1. So the cubed root of 1,000 is 10. And then I'm going to square it. And then I get 1 over 100. Now, if you were to have squared 1,000 and then find the cubed root, you can do it, but it's going to start getting your numbers really big. So if at all possible, always find the root first and then square it. There will be the few occasions where you can't find the root first. You would have to square it first. All right, let's try the next one. Now, for this one, remember there's no parentheses here. So what this is really saying is the only thing that's being raised to the 1/2 power is the 100. So really what this is saying is it's like a -1 times the square root of 100. So then -1, the square root of 100 is 10. And then when I multiply that, that answer is -10. So be very careful when the bases are negative. Now, let me just jump down to number 8, and then I'll go back to 7. Notice number 8 looks very similar to number 6. The only difference is that -100 is in parentheses. So watch what happens on this one. What's really happening here is that -100 is what's going under the square root symbol. Now, perhaps you've remembered from your middle school days that whenever you had a negative number under a square root, your teacher probably told you that it was impossible or there was no solution. Because when you try to square root a negative number, it's going to give us an imaginary number. So for right now, if you get a question like this, the answer is no solution. And that's the 0 with the slash. Coming up later in the course, we're going to learn how to square root negative numbers, and that's going to give us an imaginary number, and we're going to include the letter I. So later on, what this will actually give us is 10i. However, for right now, until we learn about imaginary numbers, if I ask you to find the square root of a negative number, you tell me no solution. You can find the cube root of a negative number, but not an even root of a negative number. So let's go back. So now let's go back up to number 7. Notice the base here is negative. However, the root we're finding is an odd root. We can do this. So for example, we're going to take the -64. We're going to put it under the radical, but we're finding the cube root, and then we're going to square it. So I can actually find a number multiplied by itself 3 times that will give me -64. And that number is -4. Because -4 times -4 is +16. And then when you multiply it one more time, it actually gives you -64. So you can find the odd root of a negative number, just not an even root of a negative number. Not yet. And now I'll square that, and I get +16. Next we have 27 raised to the 4/3 power. So again, remember the denominator is the root you're finding. So again, I'm finding the third root, or the cube root of 27. And then I'm going to raise that answer to the 4th power. I know that 3 times 3 times 3 is 27. So the cube root of 27 is 3. And then now I have to raise 3 to the 4th power. And that will give me 81. And again, remember, when you're finding these without a calculator, you can either choose to go this and get a 9, and then do it again and get 27, and then finally do it again and get the 81. Or if you prefer, I like to do them 2 at a time. So I like to do 2 at a time, and then easy enough, 9 times 9, 81. Whatever way is going to work for you. The next one, again, the denominator is the root, so it's a 2, so I'm doing the square root of 64, and then I'm raising that answer to the third power. The square root of 64, 8 times 8 is 64, and then now I need to multiply 8 times 8 times 8, so 8 times 8 is 64, times 8 again, and that gives me 512. And again, you'll do this without a calculator on Thursday. The next one, notice this denominator is an odd number, so I can find the fifth root of negative 32. So I'll go ahead and figure out what number times itself. 5 times will give me negative 32. And then I'm also going to take care of that negative exponent. Let me rewrite this here a little. I need to put it under a 1 because it's a negative 4/5. So 1 over negative 32. And then I'll make the power positive. Then the next thing I'm going to do is put it under a radical. Find the fifth root. Then raise it to the fourth power. I know that negative 2 times negative 2 times negative 2 times negative 2 times negative 2 will give me negative 32. And then now I raise that to the fourth power. So 2 times 2, 4, times 2, 8, times 2, 16. So 1/16. Remember, when you have a fraction raised to a negative exponent, let's flip it to the reciprocal. So I'm going to make this 100 over 121. And then now I can apply that rational exponent. Now, if it's easier for you to think of, I'm going to just square root the numerator separately from the denominator, find those roots individually, and then I'm going to cube my answer. So the square root of 100 is 10. The square root of 121 is 11. And now I have to apply that exponent of 3 to both. So 10 times 10 times 10 is 1,000. And then 11 times 11, 121 times 11 again, 1,331. And remember, no calculators yet. Okay, for the next one, you're going to be like, oh my goodness, do I do these separately? Remember, when the rules for multiplying numbers that have the same base, we take those exponents and we're going to add them. So I'm going to keep a base of 6, but then I'm going to take their exponents and I'm going to add them. Whenever you add fractions, you need to find a common denominator. It already has a common denominator, so I'm just going to add the numerators. 4 plus 2 is 6, so I get 6 to the 6 over 3 power. I could simplify that exponent. 6 divided by 3 is 2, so 6 squared, and my answer is 36. Remember, when you divide numbers that have the same base, you're going to take those exponents and subtract them. So I keep the 125, and then I'm going to take 7/3 and subtract 5/3. So then once I subtract it, I get 125 raised to the 2/3 power. Now I have to evaluate that rational exponent. Remember, the denominator is the root, so I'm going to find the cubed root or the third root of 125 and then square that answer. The cube root of 125 is 5, because 5 times 5 is 25, times 5 again would give me the 125. And then square it, and final answer is 25. Same thing if your base is a variable. I'm still just going to take those exponents and add them. They both have a base of r, so I'm just going to take and do negative 8/9 plus 17/9. This will give me r to the 9 over 9 power. And whenever you have the same number divided by itself, it'll simplify to a 1. So the final answer here is either just r to the first or just r. Remember, when you add and subtract integers or fractions, when the signs are different, you subtract and keep the sign of the bigger number. So here I just did 17 minus 8, I got 9, and then 9 over 9 simplified to a 1. All right, so for this one, they want us to simplify. So for this one, you can go about it different ways. You could move the negative exponent up, or you could just add it the way it is. You have different options here. So if you want to take care of this, if you want to do it this way and move this up, that's one way you could go about it. So it's z to the 3/4, and then this would become z squared, and then z to the 5/4. But then now what you need to do is for the numerator, you need to add these. So what I would need to do is turn this 2, so it has a denominator of 4. So I'm going to change it to z to the 8 over 4, and then I have the 3/4. So then I could get z to the 11/4, and then now I subtract when I divide. So 11/4, so now I have z to the 11/4 minus 5/4, which is going to give me z to the 6/4, which I need to simplify to z to the 3/2. So if they just want you to simplify and leave it with a rational exponent, that's what you would do. If they want you to get rid of the fraction, you could say it's the square root of z raised to the 3rd power. I would be looking for you to leave it just like that. For the next one, this power of 15 is only for the numerator. Remember, when you raise a power to a power, you're going to multiply. So I'm going to multiply 1/5 times the 15, and that's going to give me z to the 3rd. And then I'm going to multiply it here. So what I'm doing is 2/3 times 15 over 1. I like to simplify. So this will give me 10 over 1. So the y becomes y to the 10th. And then I have the x in the bottom. And now the only thing I need to do is take care of these x's. And I'm dividing them, so I subtract. So then this will now become x y to the 10th as your final answer. And then number 18, same thing. You're going to apply that power to the power. So we're going to multiply it. So for the numerator, it's really 3 over 1 times 1/4, which is going to give me 3/4. So p to the 3/4 power. The denominator, same thing, 5 over 4 times 2 over 1. Now, instead of simplifying, watch what I'm going to do here. I'm going to leave it 10 over 4. I could have simplified this and made this a 1 and a 2, and then it would have been p to the 5/2. But remember, I need to subtract these powers here, so that's why I didn't simplify, because now what it is it's p to the 3/4 power minus the 10/4. I'm subtracting the powers. And then this is going to give me p to the negative 7 over 4 power. I don't want to leave any answers as negative exponents, so I'm going to move it to the denominator. Put it under a 1. And that's how I'll expect you to leave these with the variables where you can't figure out what p is. Recognize on a standardized test, they might have it as the 4th root of p and then raised to the 2nd power, and then the whole thing's under 1.